Good afternoon. Thanks for giving us opportunity to come and present here on this platform. So the research paper my team was working on was detection and classification of different types of tumors using image analysis and CNN. So the research concentrates here to use on ML and AI related model using techniques like deep learning techniques for the tumor detection. So we are considering here 3 types of tumors, which is brain, breast, and the other histopathological images for early detection and diagnosis of the tumor. So this is the table of contents for the presentation. So talking about my paper, existing solutions uses different linear techniques and detect the tumors in a particular body part. And many of the techniques, it's been found that they are not accurate. So we had the team has spent some time to find out increase the accuracy with respect to and creating a user-friendly model by giving them a web application so that doctors can use it in a better way. So we had tried to reduce the number of errors and increase the efficiency of our model. So the goal here is to perform the analysis using suitable statistical and machine learning models to detect the tumors. The literature survey, what we had done, we found that many of the present research, which was done already, so they are using a logistic regression model, which had a lot of correlation errors. And then the data sets, there are very few data sets in this particular area. Then the models are also limited because some of the CNN or deep learning models where it has been found that they are giving better results on smaller data set, but won't able to give a better results on a bigger data sets. So solution is we had proposed a model which is using a Keras, TensorFlow, and all those ML techniques to detect these 3 types of tumors, which are brain, breast, and skin. So these are some of the papers which are listed here down. The references are mentioned at the end. So K-means cluster segmentations, then deep learning techniques, CNN, they had given an accurate result. Some of the CNN models had given an accurate result, but we had found that the interface was not user-friendly in certain cases. So we are trying to give all together in in this research. Objective here is to design or build a ML model to predict a tumor in brain, breast, and skin cancer related tumors. Sorry, it gives the least errors, and the number of false positives are less compared to the other models which were there. Using sufficient and good quality data set, we tried to increase the accuracy. We had tested the model, whichever the present data sets were there, the benchmark data set, we could get it. Then we had used a deep learning technique, which is a CNN based technique to achieve train the model. And the model is successfully able to classify the tumors with a accuracy which is more than 90%. So coming to a proposed system. So let's talk about this is the architecture of the proposed system, where if you can see that this breast cancer, brain tumor, and skin cancer related databases are taken. These datasets are trained using the TensorFlow, Keras, all these models, and stored. Then there is a doctor who is using our GUI, graphical user interface, where they can input the data, and immediately the result will become as whether it is a benign or a malignant tumor, or whether it has any cancerous tumors or not. So this is a typical data flow diagram, which is having a medical staff coming in, logging into a page, choosing a type of the cancer to be diagnosed, because there are 3 types of diagnosis the doctor can make using this system. Then patient-related information, the doctor has to upload the image, and after uploading an image, once the model can, the image will be checked by our model, and immediately the result will come. Coming to an implementation, so implementation covers algorithm, variables and parameters, dataset and metrics. So this is a typical, this is a algorithmic design that what we are following. So mostly the training sample, in the training phase we had applied the batch normalization. We had used a convolution neural network and max pooling system. All those together we had fed to the CNN based feature learning network. And we had trained and tested our samples using our model. And finally, the output comes as whether the image has such kind of cells or not. Here are the variables and parameters. So input colors, image size, using the batch normalization, that is what we had used. So the first layer contains 64 kernels. The second layer contains 128 kernels. The third layer consists of 256 kernels. Default size is 2 by 2 after each layer. If you can see that every time it is double. The dropout rate was in the range of 0.3 and 0.2, where where the typical batch of the images will be dropped out so that the model can to avoid the overfitting of the model. Then we had used this particular parameter was ReLU or rectified linear activation function, which is used in each step to pass the image only if it is positive. This particular function parameter is very important. So here is a data set information. So these are the 3 data sets that we had used: brain MRI images, breast MRI, and histopathological images, and image patches of the skin are used. Direct images are used. Some of them, the model is tested with the neural, these are the data sets, and we had tested our model. Apart from that, we had also tried to give some of the random images from Google, which was on the tumors, and the model was able to successfully detect them. Images are normalized to a standard size in order to overfit and underfit the data to get a better accurate results. So if you can see that all these models, brain model or skin model or breast model, and every time after every epoch, the accuracy is increasing for each and every model. Coming to results and discussions. So
you have 2 minutes to conclude, please.
Yes, thank you. So development of suitable training and testing model, we had tried to propose that model. The brain tumor was tested with 4,500 images and 4,399 images for the accuracy, and we had achieved 98.91%. The breast cancer was trained with 1,230 benign images and 1,370 malignant images, and we achieved 90% accuracy. Wherein skin cancer, we had got accuracy of 96%. So these are the results from our proposed system. Here is the accuracy plot for brain, skin, and breast. The accuracy also table is also shown. And this is this particular screenshot is taken from our proposed system. So the doctor has to choose the image and the result will come immediately. These are the results of the proposed system model. To conclude that we can overcome the challenges, especially in country like India, we need such kind of model which is suitable for, which can be like user-friendly model for the doctors to access. Then future scope, this model can be extended for the Android and iOS application. Different parts of the model, this tumor detection can be carried out for different parts of the body and can be hosted by using the cloud platform. These are the references. Thank you.
My presentation topic is a multivariate logic model for corporate bankruptcy forecasting. My name is Hongnong Chen from National University of Tainan, Taiwan. Presentation outline, introduction and background, research methodology, results, and finally conclusion. Introduction and background. Whilst the idea of performance relates to how successful an organization attains objectives or executes a strategy, it is relative performance that stands at the core of the literature on predicting corporate financial failure and bankruptcy. Not surprisingly, numerous academics and practitioners conduct extensive studies to develop bankruptcy classification models through examination and identification of determinants of corporate bankruptcy. A review of financial literature suggests that testing the actual predictive power of these models yields somewhat disappointing results. This disparity between ex-post and ex-ante results is due principally to differential industry effects and data instability over time. Therefore, to remedy this problem, we propose a simple equation to stabilize financial variables and therefore develop a relatively stable logic bankruptcy function over time. Research methodology, the data. Our sample of bankrupt companies include companies that encounter bankruptcy or liquidation events as defined by the CompuState database. Because of data accessibility, our study period is limited between 1986 and 2008, resulting in 129 companies, including in bankruptcy. We select a sample of 129 non-bankrupt companies from CompuState to match the bankrupt companies. The data sets were split into two subsamples, the in-sample data and the out-of-sample data. We use the in-sample data to build models. The data includes information for 158 equally matched bankrupt and non-failed companies from 1986 to 1995. We use the out-of-sample data composed of 100 equally matched bankrupt and non-failed companies between 1996 and 2008 to study the predictive ability of the models. Research methodology. We use a twofold methodology to develop bankruptcy prediction models. First, we propose an exponential function-based algorithm to transform 16 financial variables that are potential bankruptcy determinants. The selection is based on literature review. The equation, as you can see right here, okay, which is a Tx equal to exponential divided by 1 plus exponential, where xik is the kth financial variable of the ith firm. Second, we conduct a multivariate logistic regression analysis with backward elimination of the financial variables. Validation of the final bankruptcy model is by out-of-sample type 1, which is a bankrupt company sample accuracy. Type 2, non-bankrupt company sample accuracy and overall correct classification rates. Industry relative ratios are used to compare with our proposed formula. Table 1 shows bankruptcy classification models created with multivariate logistic regression analysis with backward elimination. This is based on 158 firms. As you can see, the process goes through model 1 to model 13, and model 13 is the final model, which consists 4 variables. From cash flow category, there is 1 variable. Capital structure and solvency, 1 variable. Probability performance, well, there is no variable. Operating performance, we have 1 variable right there, and market, there is also 1 variable. So basically, this model includes, in the final form, 4 variables. Table 2 show ex post and ex ante classification accuracy of model 13 in sample for model building and out of sample for model validation are 158 and 100 firms respectively. As you can see right here, this is our model. In sample is which is 10-year period. It is for in sample bar data, it is 97.8 accuracy, survival 100% accuracy. Out of sample is 13 years. This is 91.89 for survivors, 97.3. Overall accuracy is 94.59. When you look at the model is with relative industry relative ratios. In sample accuracy is 10-year period. Likewise, it's 97.83. All of them are 97.83, and out of sample 13 years, for failures 89.91, survivors 86.49, and overall is 87.84. So basically, our proposed model outperformed industrial relative ratios. Research results. The result shows that the overall in-sample classification accuracy with IRRS is slightly lower, but the difference between in-sample and out-of-sample classification result with IRR is considerably larger. This suggests that our proposed method is sufficiently robust so as to develop a relatively stable model specification for bankruptcy forecasting. Conclusion. This study develops a corporate bankruptcy classification model from a sample of 258 bankrupt and non-bankrupt companies covering a period of 23 years. Instead of developing on traditional ratios, use a simple exponential function-based algorithm to improve the stability of the financial data. The model shows high classification accuracy and relatively small differences in classification rates between in-sample and out-of-sample as compared to industry-relative analysis. The model appears to be robust. However, future research to use more example to further validate our model. This is my presentation.
Thank you very much for your presentation, and I appreciate your joining for